Back in 1986, a paper dropped that pretty much shook the foundations of software engineering, and people are still arguing about it decades later. So today, we're reloading No Silver Bullet, taking a look back at Fred Brooks's legendary essay and asking the big question, 20 years on, did we ever find a way to slay the monsters in our code? All right, let's get into it.
So Brooks kicks off his paper, not with a bunch of tech jargon, but with a straight-up horror story. He compares a software project that's gone off the rails to a werewolf. Think about it. It's something familiar, right? A project that seems fine, a team you trust, that suddenly, terrifyingly, morphs into this uncontrollable monster that's devouring your schedule, your budget, maybe even your company. It's such a powerful metaphor, and honestly, a feeling that a lot of us in this field know way too well.
And just like in the old stories, we're always on the hunt for a magic fix, a silver bullet. In the software world, that means some single incredible breakthrough, a new language, a new framework, a new methodology that would give us a massive order of magnitude improvement. We're not talking a 10% boost, we're talking a 10 times boost in productivity and simplicity. So the central question of Brooks' paper and for us today is, does that magic bullet even exist?
To answer that, we've got to first understand the nature of the beast we're actually hunting. What is it that makes building software so monstrously difficult in the first place? So let's go right back to the source, Fred Brooks's original diagnosis from 1986. His entire argument was built on this one incredibly important distinction, one that completely changed how we talk about software problems forever. Here's his big idea. He said that all the difficulties in building software can be split into two buckets, essential complexity and accidental complexity. And really, getting the difference between these two is the key to unlocking his entire argument.
Okay, so essential complexity, that's the stuff that's just plain hard because the problem itself is hard. It's the tangled mess of business rules, all the weird user needs, the complex logic that the software has to have. It's the very nature of the beast. Accidental complexity, on the other hand, well, that's kind of the self-inflicted pain. It's the clunky programming languages, the slow compilers, the nightmare debugging tools we used to have to fight with just to get anything done.
So here's how Brooks lays it out. He argued that all the huge leaps forward we'd made in the past, like moving from assembly to high-level languages, were all about solving accidental problems. Then he makes this really bold claim. By 1986, he figured at least half of the difficulty we had left was essential. So here's the kicker. If that's true, then even a perfect tool that gets rid of all the remaining accidental complexity could at best only double our productivity. That's a big deal for sure, but it could never be that silver bullet that gives us a 10 times improvement. All right, now let's jump forward 20 years to 2007. A panel of absolute software legends, including Brooks himself, got together to ask a simple question. Was he right? What actually happened in the 2 decades after he made that famous prediction?
So the panel did find some common ground. They all agreed that a few things did make a huge difference. Object-oriented programming, for example, they saw as a real attempt to attack that essential complexity head-on. Martin Fowler pointed to iterative development and the whole agile movement as one of the great leaps. And of course, everyone agreed that the explosion of open-source libraries and pre-built software was a total game-changer. As Brooks himself put it, the most radical possible solution for constructing software is not to construct it at all.
But here's the thing. It wasn't all about the tech. Martin Fowler made a great point that one of Brooks's most important messages often gets lost in the shuffle, the absolutely crucial role of great designers. You can have the best tools in the world, but in the hands of an average designer, you'll only get so far. The real breakthroughs, they still come from people.
Okay, but this is where the friendly agreement stops, and the debate gets really interesting. Some of the panelists started to argue that while we were busy solving all those old problems, we might have been accidentally creating entirely new werewolves, maybe even worse ones.
And then you have David Lawrence Parnas, who just comes in with this firecracker of a counter-argument. He basically said that Brooks's whole idea of accidental complexity just lets us off the hook. He argued the problem isn't our tools, it's our lack of professionalism and discipline in how we use them. The mistakes we make, he said, are just violations of principles we've known about for years. So, for example, you have Martin Fowler praising iterative agile development. He sees it as this huge leap forward that helps teams get working code out the door faster than ever. But Parnas, he saw it completely differently. To him, a lot of the stuff the Agile movement was pushing, like cutting back on documentation and detailed planning, wasn't new at all.
He just called it business as usual. The same old, undisciplined habits that developers have always had, just repackaged and sold to us by a new set of gurus. Ouch.
Another panelist, Dave Thomas, took this critique even further. He argued that we have actively increased accidental complexity over the years. Our languages have way more features. Our frameworks are this constantly changing sea of APIs. And open source, while amazing, now means you have to understand these massive external codebases. It feels like we're fighting complexity with, well, more complexity.
And just when you think the debate is all about tools versus discipline, Aki Namioka comes in and reframes the whole thing. She suggested that maybe the biggest problem isn't technical complexity at all. Maybe it's something way more fundamental. Are we even building products that meet what users actually expect? I mean, no matter how beautiful your code is, if it doesn't solve the user's real problem, it's a failure, plain and simple. This brings us to a really different take from Ricardo Lopez. He proposed that the true silver bullet isn't a piece of tech you can buy or a process you can install. It's about the relentless pursuit of personal and professional excellence. That order of magnitude improvement, he says, has to come from inside the developer themselves. So, after all this back and forth, all this debate, where does that leave us? If there's no single magical silver bullet, are we just doomed to fight these werewolves with our bare hands forever?
Well, not quite. The panel didn't find a silver bullet, but what they did offer was a whole collection of what you might call lead bullets. These aren't magic, and they're definitely not easy. They're the hard-won practical things. We have to invest in and cultivate great designers. We have to demand craftsmanship and personal excellence. We need to apply rigorous, science-based discipline, just like other engineering fields do. And maybe most importantly, we have to stay relentlessly focused on what the user actually needs.
And that brings us right up to today, doesn't it? I mean, all the conversation around AI code generation. It has that same silver bullet hopefulness of the past. It promises to slay the monster of tedious coding. But as we've learned from Brooks and all the debate that followed, we really have to ask ourselves, is this technology finally the silver bullet we've been waiting for, or are we just creating a powerful, new, and completely unpredictable kind of werewolf?